Okay, Math 161, Chapter 2.5, the properties of graphs. Okay, first let's check, how to test for symmetry with respect to the x-axis and the y-axis. Okay, that means there is a graph. Here's x-axis, y-axis. Okay, we know that the graph of y equals x squared. What's the graph of x squared? Isn't it the parabola U shape? Opens upward, right? Opens upward. Looks like this. And as you see this one, let's say x equals 1, then y is 1, and x is negative 1, then y is also 1, right? So, when you replace the variable x with negative value, negative x, then y is still the same. Can you see it? So in this case, f of 1 is 1 squared, which is 1, right? And f of negative 1, we will replace x with negative value, then negative 1 squared is 1. So these y values are the same. They are the same, right? So if those y values are the same, then what? What do you call this one? This graph is symmetry with respect to the y-axis. So it's a common sense, positive x and negative x, and they have the same y value. So that this distance is the same, right? So this distance is the same. So this point come to the other side. Then we said, it's a rotation, right? Rotation about the y-axis, still the same, right? So we call it symmetry. This graph is symmetry with respect to the y-axis. How to check? Change x with the negative value, then y will be the same. Okay, how about with respect to the symmetry with respect to the x-axis? Okay, for example, for x-axis, let's use something like this. Y equals, or x equals y squared. X equals y squared. And this graph is this. This graph is this. This is x and y. Then this graph is symmetry with respect to the x-axis, because look at this. If x equals 1, then what's the y value? X equals 1, then y squared. So y equals plus or minus 1, right? Plus or minus square root of 1, which is plus or minus 1. So y will be positive 1, also will be negative 1, right? So in that case, replace y with positive value 1. If y equals 1, then x will be 1 squared is equal to 1. If y equals negative 1, then x is negative 1 squared, which is 1, right? So these x values are the same this time. So there are two y values. One is positive, one is negative in this case. So there are two of them. So plug in y with the negative value, then you have the same x value. Can you see it? So look at this. Plug in positive y, then you get x. Negative y, you get the x. But these x values are the same. So replace x with the negative value, then x will be the same. Then that is the graph that is symmetry with respect to the x-axis. So if it's confused, then draw a diagram like this, x squared graph and the y squared graph. So x squared is symmetry with respect to the y-axis. So as you see this one, positive x. So replace x with negative x, and then the y value is the same. Okay, for the x-axis, symmetry with respect to the x-axis, then what do you replace? Y. Okay, replace y with negative y. Then you will share this same x value. All right, then example 1, AB. For AB, let's find out whether the graph of this equation is symmetry with respect to y or with respect to the x-axis. Okay, first let's check replace. Okay, let's replace x with negative x and then see what happens. All right, then y equals, okay, x, just plug in x is negative x, right? X is negative x. And this one is equal to negative x squared is x squared plus 2, right? And this one is also y, isn't it? Y. So same y, right? Same y. Okay. Let me use a different notation. I think this is better. Okay, I'm gonna use f of negative x. Okay, negative x. And this one is f of x, right? Because y is f of x, and same notation. Then negative x squared plus 2 equals x squared plus 2. And this is exactly the same as f of x, right? So when x is replaced by negative x, and it became f of x. So this one is what? Symmetry with respect to what? Respect to the y-axis. Okay. If we plug in y with negative y, then it will not the x value will not be the same, because if we plug in on negative y, then what happens? Negative y is equal to x squared plus 2, right? If you rewrite it, then y equals negative x squared, minus each, multiply negative each side. Then this is not y, okay? This is not y. This is not equal to y, right? So this is not symmetry with respect to the x-axis. It's only symmetry with respect to the y-axis. How about the next one? Okay, in this case, let's plug in x into negative x and see what happens. So x is negative x, right? Equals this. Then multiply negative each side of the equation. Then this one. And this is not equal to y, right? So this is not equal to x. Not equal to x. So this is not symmetry with the y-axis. So let's try replacing y with the negative y. Negative y. Then x equals absolute value of negative y. Absolute value of negative y minus 2. Then negative can go outside, but it becomes positive, right? Positive. Always the negative sign can be positive once it gets out of the absolute value symbol. So we have this, and this one is exactly same as x, right? So this is symmetry with respect to the x-axis. X-axis. Okay, symmetry with respect to the x-axis. Okay, there's another definition of symmetry. Okay, a graph is symmetry with respect to the origin. Okay, origin means the origin is this one, 0, 0. So let me sketch a graph of y equals x squared, y equals x cubed. Okay, so in this case, if x equals 1, then 1 cubed is 1, right? How about negative 1? If x is negative 1, then y is also negative 1. Negative 1. All right, so if a graph is symmetry with respect to the origin, then it looks like this. So that means once you plug in, replace x with negative x, replace x with the negative x, then the y value will be negated. The sign of the y will be different. So if x equals 1, then the y is 1, right? Y is 1, positive. In this case, positive 1. But if we plug in negative 1, then the y value is negative 1. Because, the opposite of 1 is negative 1, right? Like this. So the result will be when x is replaced by negative x, then the y value will be negative y value of x. Can you see it? So we call this, so this type of graph is symmetry with respect to the origin. So in that case, here's a very important concept. If a graph is symmetry with respect to the y-axis, the first one, y-axis, then we call, if this is a function, then we call this function is odd function, even function. We call this what? Even function. Okay. If it's symmetry with respect to the y-axis, then we call it even function. And then if the graph of a function is symmetry with respect to the origin, then we call it odd function. Odd function. Okay, so look at this. Look at the example. The example of y equals x squared. Y equals x squared. And this one is, this is an even function because the graph is symmetry with the respect to the y-axis, right? You know, y-axis. So look at the degree. Just as an example. If you forgot the definition, then look at this x squared example. X squared. You know, 2 is what? 2 is even, isn't even? 2 is even. So x squared graph is symmetry with respect to the y-axis. So don't forget this. And then how about this one? Odd function. Okay, odd function is this one. Look at this. X cubed, right? X cubed. And this x cubed is symmetry with respect to the origin, right? So this one is odd number. So if you think of this power, this exponent, then you will see how we test for the symmetry. Okay, x cubed. This is an example of odd function. Example of odd function. X cubed plus something does not mean it's always odd function. Okay, always you have to check. Replace x with negative x, and the result is negative f of x. Then that's odd function. Okay, then let's try some examples. Okay, let's check if the graph of the equation, following equation is symmetry with the with respect to the origin. Okay, to check symmetry with respect to the origin, then we have to try this one. Replace x with negative x. Then we will check whether this one is same as negative f of x. Okay, then let's rewrite it as in terms of x. So y equals, divide each side by x, then it's 1 over 4, right? So so this is f of x, this is f of x, right? Divide each side by x, so 4 over x. All right, then we will replace x with negative x and see what happens. Then 4 over this x is replaced by negative x. Then negative sign can go outside. Then 4 over x. As you see this, what is 4 over x? That is f of x, isn't it? So negative f of x. So as you see this satisfies the definition of the symmetry with respect to the origin. So yes. The answer is yes, is respect. So that is symmetry with respect to the origin. Okay, and the next one, this is x cubed plus 1. All right, let's try the same thing. Then we can rewrite it, replace y with f of x. It doesn't matter. I just want to help you, understand what x value is. So in that case, let's test with negative x. So replace x with negative x. Then negative x cubed plus 1. Then simplify it. So negative x is multiplied 3 times. That means the x can go outside and like this. And is it same as f of x? No, right now, because f of x is, this one is x cubed plus 1. This is different, right? Different. So this is no, this is not, the graph is not symmetry with respect to the origin. Okay, so since xy equals 4. This equation is respect to symmetry with respect to the origin. This function is odd function, right? Odd function. So let me rewrite it. We will do the odd function and even function next example. So this one is what? Odd function or odd function. It's just like, it's respect to the origin, respect to the origin. That means it looks like this, x cubed, something like this, right? All right, then let's try next. Okay, next example is to determine whether each function is even, odd, or neither. So even function is what? Okay, we will test like this. Replace x with negative x, then this one is same as the y value. Then that's even function. And odd function, if when you replace x with negative x, then it will be negative f of x. Then that's odd function, and neither is none of this. All right. So let's try this. So replace x with negative x, then it will be negative x cubed. So that is negative goes outside and x cubed. And this is equal to negative times, what is this guy? F of x, right? So since this one satisfies the definition, this one is even function. Okay. How about the next one? Okay, replace x with what? Negative x. Then absolute value of negative x equals, this negative sign can be removed, absolute value x. So that is equal to, back to the original function f of x. So this one is even function. All right, next one. Okay, h of replace x with negative x, then negative x squared fourth power plus 2 times negative 4. Then x to the fourth power is what? Positive x to the fourth power, and this minus sorry, this is gotta be a 4, right? X, what am I doing? So replace x with negative x, so that will be minus 2x. And is it same as h of x? No, right? No, because h of x is, this one is x to the fourth power plus 2x. This is plus 2x, this is minus 2x, right? So it's different. So this is not even. This is neither, right? Neither. But look at A and B. Okay, sorry. A is what? Odd function, is an odd function. Sorry for this one. Okay, A is odd function because negative sign. So the y value is now became an opposite of the y value. So it became negative, different sign. So it is odd function. And B is same as the original function. So that is the y value same y value with different x values. Positive x and negative x has the same y value. So B is even function. Okay. Okay, next definition is about translation of graphs. Okay, in this case, the translation means shift, shift up or down, or shift right to the left. So vertical translation, translation means shift. Okay, this means shifting. Okay, shift. So vertical translation, vertical shift, it can be shift 2 units up or 2 units down, up or down, up or down. So that means, okay, it's really simple because let's look at an example of y equals x squared. Let's say f of x is equal to x squared. Then the graph is opens upward like this, and then if you move the graph 2 units up, then what happens? If we move it 2 units up, then 1, 2, right? So the graph looks like this. So this means, let's say this is g of x. Then this graph is, with the same value x, the y value is increased by 2. So the same value is what? Same value y. The same value y. Let's say f of x equals 0. Then originally the y was 0, the y was 0. But once you shift 2 units up, then this y value is increased by 2. Increased by 2, right? Increased by 2. So what we do is add 2 to the original function. To the original y value. Okay, so this is the y value. Okay, this is the y value, right? Y value. So what we do is add the number of units you want to shift up. So just add it to the y value. Okay, that is shift up. How about shift down? So how about this one? Let's g of x is, okay, let me use k of x. This time let's use h of x. Okay, h of x. Then this h of x is the original y value. Okay, f of x means y value, right? And then I'm going to subtract 2 units from here. That means, in that case, we can redraw it. So the original y value is decreased by 2. And it looks like this. It looks like this. So this is h of x, right? And this h of x is the original y value, which is f of x, is decreased by 2. So negative 2 means this is shift down 2 units. Shift the original graph, f of x, the graph of f of x, 2 units down. So that is a vertical translation. Can you see it? So we subtract 2 from the original y value. Okay, so shift down. So this one is simple. Shift up and shift down is really simple because what we do is add or subtract, a number from the original y value. Okay, about the next one. Next one is the horizontal translation. The horizontal translation is we are moving the graph to the right or left. Okay, so this time let's check, shift the graph, original graph to the right or to the left. Here is x-axis, and then this is the y-axis. Okay, this is y equals x squared. Okay, x squared. All right, I want to shift this one 2 units to the right. So this is 0, so 2 units to the right. Then, this 0 is moved 2 units to the right? So it's going to be something like this. And this is the function, let's say g of x. Then this g of x is really simple. What you have to do is, this time, replace x. 2 units to the right. That means we're going to subtract x, subtract 2 from x. X minus 2. So instead of adding the number to the y value, we add or subtract to or from the x value. Okay, so replace x. This means replace x with x minus 2. X minus 2. Look at this one. Minus means shift to the right. So this will be x minus 2 squared. Okay, can you see it? So when you shift to the right, what you have to do is subtract 2 from x. So replace x with x minus 2. How about going left? I want to shift to the left 2 units. 2 units to the left. Then it's going to be, looks like this, right? And move each point on the original graph to the left. 2 units to the left. Then this function is, what we do is replace what? Replace x with plus 2 this time, plus 2. Okay, so x plus 2 means shift to the left, shift to the left. So replace x with what? X plus 2. So that will be x plus 2 squared. Can you see it? So when you shift up and down, we add, shift up, then just add it to the y value. Just add it to the y value. So this will be x squared plus 2. Add 2 to the y value, which is x squared. And then if you shift down, then subtract, right? Subtract. So x squared minus 2. So what we do is subtract from what? The original y value. Then that is the graph of shift up and down, vertical translation. If you shift right or left, we replace the input variable x. Replace x with minus. X minus something, that means shift to the right. X plus something, then shift to the left. Okay? X plus something, shift to the left. X minus something, shift to the right. Okay, so this means replace. Okay, replace x with x minus something or x plus something. Then this means shift, minus means shift right. And plus means shift to the left. Okay, simple. Horizontal. And then for the vertical translation, it's straightforward. Y value is increased, then up. Y value is decreased, then down. So plus means shift up, minus means shift down. Okay, let's say this is the function f of x, the graph of f of x. Then we can get a means g of x. The function g of x is f of x plus 3. That means you are adding the y value by 3, right? By 3. So we're going to, this means shift up. Translation, vertical translation, 3 units up. Shift 3 units up, right? Shift 3 units up. So all this one will be moved 3 units. So this will be 1, 2, 3, right? Go up. So this one also move 3 units. So this point moves 3 units up over here. So the graph looks like this. This one, and then this one, and this one. So this is g of x. Okay. And then how about h of x? Okay, this means minus 2, right? Minus 2 means you are subtracting the y value, lower the graph of the y 2 units down. This means shift 2 units down, right? Down. So this point will move 2 units down. So it will be minus 3, right? Then this will move 2 units down. It will be negative 2. So the graph looks like this. Looks like this. So this is the graph of h of x. Can you see it? So y value plus means up. Y value minus means shift down. All right, next example is the graph of f of x is given, then g of x equals f of x minus 2. Look at this. This x is replaced by 2, right? Replaced by 2. So this x minus means what? Shift 2 units where? Right or left? Right. Right. So if this minus, then it is right. So I'm going to move this one 2 units to the right. So this will be moved to over here, and this point will move over here, and this point will move over here. All right. So the graph looks like this. Like this. And then this point moves. Actually, so this point moves 2 units to the right. Let me draw a little bit precisely. So this one moves up to here, right? Even this one, this point moves up to here. So let me connect these points smoothly. This is going to be something like this. And then like this. Not exactly the same, huh? Not exactly the same. Okay. Okay. I have to draw something similar to this. Like this. Now it makes sense. So this one is a g of x. So g of x is equal to what? What we did is we shifted the original graph 2 units to the right because x is replaced by x minus. Okay, minus. How about the next one? This one is x plus, right? Plus means, this plus means shift where? Shift 1 unit to the left. So I'm going to shift this one unit to the left. So this will move over here, right? And this one move over here. And this vertex will move somewhere like this. Move this one over here like this. And then this one moves over here. And then this one moves over here. So let's connect this one. Like this. Like this. Like this. Does it make sense? So this is the h of x. Okay. Okay, next example is applying both. So shift up or down and shift right and left. So this one contains all of them. So as you see this, x is replaced by +1, right? So this +1 means shift where? Shift to the left. And then -3 means you're subtracting 3 from the y value, right? Y, f of something minus. So this means shift where? 3 units down, right? Shift 3 units down. So let's shift the graph of f of x 1 unit left. Okay, 1 unit left. So this point move to here, right here. And then move 3 units down. So I'm gonna move 1, 2, 3 units down. So it's over here, right? So the vertex is moved left and right. And then from this, let's graph it. So the graph looks like this, right? Something like this. So this is the graph of g of x. Simple, isn't it? So what you have to do is, shifting. So make sure whether, plus or minus is in the x or y. So if x is replaced by plus or minus, then shift right or left. If plus or minus is added to, to the y, the whole f of x, then shift up and down, up or down. So all points in the original should move 1 unit left, 1 unit left, and then 3 units down. 1 unit left, 3 units down. Okay, 3 units down. So this graph should go across the origin. Okay, next concept is reflection across the x-axis and the y-axis. So as you see this graph, let's say y equals x squared, then this is a parabola, opens upward. And then once you reflect this one across the x-axis, then this point, let's say x equals 1, then the y value is 1. Then this y value is reflected across the x-axis, so it becomes -1, right? -1. And 0 is 0. How about this point? This point is also reflected across the x-axis, so it becomes -1 or -1. So once you reflect it, it looks like this, right? It looks like this. So for each x value, the y value changes the sign. So if the y value is positive, then positive becomes negative because it has to go down, right? Go down. So this one is really simple function. So the original f of x, so for the same x value, then the y value will become what? Negative. What you have to do is put the negative sign on the y value. Very simple. Okay, what you have to do is replace, put the negative sign on the y value. So that, okay, let me change this one. The new function g of x will be what? The original function is multiplied by negative sign. That's it. Okay, now let's consider y equals square root of x. Then square root of x graph is this. When x equals 0, y equals 0, and x equals 1, then y is 1, right? So if we reflect this graph across the y-axis, then this one, this point should go over the other side of the y-axis. So it's got to go to where? Negative 1. Because the value of this one was when x equals 1, y equals 1, right? So once this point is reflected to the y-axis, it goes to the other side, which is x should be negative 1. So the graph looks like this, right? So as you see this, the y values are same, but the x value has different sign. So when we reflect across the y-axis, then the new function will be negating, making opposite of the input value, negative x. So what you have to do is replace x with what? Negative x. Okay, so this is really important. This means replace. Okay, replace x with what? Negative x. Okay, that is how we reflect a graph of a function across the y-axis. Okay, how about x-axis? What we do is negate, make opposite of what? Make opposite of y. Change the sign of y. I would say change the sign of y. Change the sign of y. Okay, so replace x with, and then how about this one? The same as this one. Change the sign of x. All right, it's really simple. It's easy to understand. Okay, so make sure change the sign of y, then that is how we reflect the graph across the x-axis. Change the sign of x, then what? We reflect the graph across the y-axis. Okay, now let's reflect this graph of y equals f of x. Okay, look at this. The y value is, the sign of the y is changed, right? Sign of y changed. This means what? Positive y will become negative y. So positive 1 becomes negative 1. Isn't it? Reflection across the x-axis, right? So this means reflect across the x-axis, because positive 1 becomes negative 1, right? So this positive 1 becomes what? Negative 1. And if this number is something over here, I don't know what this number is, then this will move to the negative, right? Negative. So the graph looks like this, right? Okay, so this is the g of x, which is reflection, the original graph across the x-axis. So put a negative sign outside y value. How about h of x? H of x is, minus sign goes to the x, right? X. So this means reflection across what? Reflect across the y-axis, right? Because the positive x becomes negative x. So positive 1 becomes negative 1. So this is positive 1. So once you reflect to the y-axis, this goes over here, right? negative 1. So positive 1 will become negative 1. So the graph looks like this. And even this point, this is positive 2, then it goes to the negative 2 somewhere. Right? So this one goes over here, this one goes over here. Make sense? So whenever x, the sign of x changed, then reflect the graph across the y-axis. And then whenever you change the y, sign of y, then reflect the graph across what? X-axis. Okay, next concept is the vertical stretch and vertical compression of a graph. So let's use common sense. Okay, let's say this is y squared graph. Okay, y equals f of x. And let's say this is x squared. Then if x equals 1, then y equals 1, right? So when we stretch this one vertically, that means, okay, here is the vertical distance is 1. This vertical distance is 1, right? But I'm going to multiply this by 2. Let's say I'm going to multiply this by 2. So this will stretch it to 2, right? The y value will be 2. Even this one is doubled. So this height is doubled. So it will be something like this. And even this one, this y value is doubled. So it comes over here. Even this y value is doubled. So it's going to be like this. So the new graph of this function is this, right? Like this. So let's say this graph is g of x. Then each y value of the original function, because the original y value is now doubled, right? Doubled. So what we do is multiply y by the factor 2. So that's the formula. So when we do a stretch or compression, okay, let's say f of x equals, y equals f of x. Then the new function g of x. Okay, g of x is, what you do is multiply the y value, the original y value, by a number like this. Okay, so if this number is greater than 1, then that is the y value is increased by a factor of 2, right? So that is a stretch. So if this number is greater than 1, it's greater than 1, right? Greater than 1. So it's a stretch, vertical stretch. We call it what? Vertical stretch. So this is a vertical stretch. Vertical stretch by a factor of, in this case, 2. Because 2 is greater than 1. What if we are using less than 1? It's 0 to 1. So let's say h of x is equal to 1 over 2 times f of x. Then this value is what? Less than 1, right? Less than 1. Actually, not. Let's say this is positive, less than 1. Then that is a vertical compression. Then this means vertical compression by a factor of 1 over 2. So, okay, let's have an example. Same example as this one. So yx, let's say the function is y equals x squared. Okay, this is y equals x squared. Then, what if when x equals 1, then y equals 1, right? So we're going to multiply this by one half. Then this will be reduced by half, right? Half. This is 1/2. Reduced by half. And even this point is reduced by half. The y value of this point is reduced by half, so which is up around here. And even the other side is correct. It's the same. So move this one in half, and this y value is reduced by half. So once we connect all these points, it's gonna go wider. The graph gets wider, right? Wider. So this is the graph of h of x. This h of x is what? 1/2 of what? F of x. Make sense? Okay. So that is equal to 1 over 2 times what? X squared. So whenever the coefficient, or not the coefficient, whenever the y value is multiplied by a number and this number is greater than 1, then that is a vertical stretch. The y value is increased by multiplying that factor. And if this value is less than 1, then what? Vertical compression. Okay. Okay, next example is this. Okay, now f of x, the y value is multiplied by 2. So we are doing what? Vertical stretch. Right? This is a vertical stretch by a factor of 2. So each y value is increased by what? 2, right? 2. So okay, actually this is 2. Okay, this value is 2. So this one is multiplied by 2, so that becomes 4. So this point will be moved to here. Even this one, this is negative 2. So that will become what? Multiplied negative 2 by 2 is negative 4. Even this point moves here. Everything. So all the points will be multiplied. The y value is multiplied by 2. So once we connect this, it looks like this. 0 multiplied 2 is 0, right? So this one stays the same. So it looks like this. This is a vertical stretch. This is a vertical stretch. Okay. Vertical stretch. Something like this. So this is the graph of g of x. Okay, next example is we are multiplying the value of y by 1/2. So this is a vertical what? Vertical compression. Vertical compression by a factor of 1/2. So all the y value will be reduced by, not reduced, it will be multiplied by half. So this is y equals 2. So 2 divided by 2 is what? 1, right? So this value becomes 1. And 0 times 1 over 2 is 0. How about negative 2? This is negative 2. So negative 2 becomes negative 1, right? So we do the same thing for each number. Each point. Reduce it to the, not reduce, multiply by 1 over 2. So this will be like this. And then go like this. And then go here. And then here. And then go there like this. Can you see it? Reduced. So they are all reduced like this. Reduced. Multiply by half. Multiply by half. Okay, now the last concept is the horizontal stretch and compression by a factor of some number. Okay, so horizontal stretch and compression is already related to x. So we will change the x. So if x is multiplied by some number, 1 over 2, and 1 over 2 is, what's the reciprocal? The reciprocal is what? 2, right? 2. The reciprocal of 1 over 2 is 2. And 2 is greater than 1, right? Then this is horizontal compression. Then this one is what? Horizontal stretch. We call this horizontal stretch. Stretch by a factor of what? Factor of 2. So always make the reciprocal of the coefficient of x. So if x is multiplied a number, and then make sure the reciprocal of this is 2, right? 2. Then 2 is greater than 1. Then that is horizontal stretch. So look at this. If x equals 1, then y equals 1, right? So when we do a stretch by a factor of, horizontal stretch by a factor of 2, then we will replace, okay, so g of x. G of x will be f of what? Multiply x by what? 1 over 2. 2 horizontal stretch by a factor of 2. So reciprocal of 2 is 1 over 2. So multiply x by 1 over 2. All right, so that is equal to what? X times 1 over 2 squared. Like this. All right, then the graph of g of x will be, stretch this point horizontally twice the x value. So it becomes 2, right? So this one will be now 2. All right. Even this number will be multiplied by 2. So probably somewhere over here. And if it goes, how about this one? Let's say this is -1. Then this one should move to where? -2, right? -2. So the graph will be like this, stretched, horizontally stretched by a factor of 2. Can you see it? Horizontally stretched by a factor of 2. It became wider, right? Wider. So horizontal stretch is same as what? Is it similar to vertical compression, right? Vertical compression, because it becomes wider. All right, then let's try horizontal compression. So if x is multiplied by 2, then what's the reciprocal of 2? Reciprocal of 2 is what? Is 1/2, right? Then 1/2 is less than 1. So this is horizontal compression. There's a rule, so just follow the rule. So this is horizontal compression by a factor of what? 1/2. Okay. So if x is multiplied by 2, x is multiplied by 2 means what we do is make a reciprocal of 2. So it's a compression by a factor of 1/2. Okay, don't get confused. Okay, let me try this one again. So this is x-axis and then y-axis. Let's say this is the graph of y equals x squared. Okay, x squared. So let's say y equals f of x. Okay, f of x. So that is x squared. Then once let's make a g of x. Okay, g of x is, we're gonna multiply x by 1/2. By 2, right? By 2. That means 2x squared, right? 2x squared. So since x is multiplied by 2, then what's the reciprocal of 2? 1/2. So 1/2 means compression, horizontal compression by a factor of 1/2. So if x equals 1, then y is 1. So this x value, the horizontal compression by 1/2 means the horizontal distance is multiplied by 1/2. So it becomes 1/2, right? So this one comes over here, and this one should comes in half like this. Even this point moves half. So the new graph will becomes narrow, right? Narrow, like this. Can you see it? So when we change the x, the variable x, then always think the reverse way. Think the opposite way. So if x is multiplied by 2, that means, it looks like, x is increased, right? Horizontally increased, but no. The x is compressed by a factor of the reciprocal. Okay. So if x is multiplied by 1/2, then it looks like, the x value is reduced, right? But actually it is horizontal compression by a factor of the reciprocal, which is 2. Okay, so the horizontally stretched by a factor of 2. Okay, don't get confused. So let's try some example. Okay, for this example, now x is multiplied by 2. So the reciprocal is what? Reciprocal of 2 is 1/2. So this is a horizontal. Since x is multiplied, so it will be either horizontal compression or stretch, right? But the reciprocal is 1/2, so it is a horizontal compression. This is a compression by a factor of 2, 1/2. So all the x value will be multiplied by 1/2. So this one, so the x value is 1, right? So this is reduced by half, so comes over here. And then this one comes over here, right? Over here. and then 4 becomes 2, right? 2. So let me plot this point. So instead, okay, let me use, okay. So this point becomes over here, and then the new point for 2 is over here, and new point 4 is this one, and new point for this is, okay, this is 3, right? This is 3, so it's got to be 1.5, and even this -1, so this -1 becomes over here, and -2 comes over here, and this -3 comes 1.5, something like this. So the graph will be horizontally compressed by a factor of what? By a factor of 2, 1 over 2. Okay, so it's gonna go something like this. This one goes up and then go down, and this 4 becomes 2, right? Like this, and go like this. All right, so what this one, so this one is the all the x values is what? Is multiplied by 2. So this one is multiplied by 2, multiplied by 2. Compression. So all right, and this point moves over here, this point moves over here, and this point moves over there, and this one, they all multiplied by 1/2. Okay, the next one is x is multiplied by 1/3, right? 1/3. So 1/3 means what's the reciprocal? Reciprocal of 1/3 is what? 3. So this is horizontal because x is multiplied by something. There is a horizontal stretch or compression. But since the factor is 3, it's a horizontal stretch. Stretch by a factor of what? 3. So all the x value will be multiplied by 3. So the x value for this point is 3, right? 3, so we're going to multiply by 3. So 1 becomes 3. So this point should move to this position. And this one, and 3 becomes what? Okay, how about this one? 2 should move to 6, right? 6 over here. And then this one should go all the way to the 9th, right? 6, 7, 8, 9 over here. It's a stretch, horizontal stretch. So for this point, the x value is -1, so this one should go all the way up to -3. And this point, -2 multiplied by 3 is -6. So it's got to go all the way to here. And this is 3, right? So 3 got to go all the way to 9. All the way to the 9. So once we connect these points, it will be, comes over here. Comes over here, and then comes over here. This is not drawn in scale. So it comes over here, and then this one still goes all the way to 9, right? And then this one moves to -3 over here, and then this is -6. This is -6. So -2 moved to -6 at this point. So it's got to go like this. Okay, so that is a horizontal stretch by a factor of 3. All right, so I think, I'm going to, let me summarize this transformation. Okay, let's do the summary of the transformation. So there are vertical shifts up and down, horizontal shift right and left, vertical stretch and compression by a factor of some number, and the horizontal stretch and compression by a factor of some number. Okay, so first, the vertical shift to unit up. That means, okay, you get the g of x. The new function g of x will be what? In this case, we will add the y value by the number 2. So this is a vertical shift 2 unit up, right? How about this one? The vertical shift 2 unit down. That means subtract the number from y. How about the horizontal shift 2 unit right? The horizontal shift is what? You change the x value, right? Change the x value. So it will be x. If you go right, then this will be x minus 2. Okay, minus 2 means go right. And then shift 2 unit to the left, that means change x, so x will be x plus 2. So replace x with x plus 2. All right. And then vertical stretch. Now, vertical stretch means, so the new function will be what? Multiply f of x by the number 2, which is greater than 1. That's the vertical stretch. And vertical compression is multiply y value by less than 1, which is 1 over 2. How about the horizontal stretch? The horizontal stretch is multiply x. So I'm going to multiply x by the reciprocal of 2, which is 1 over 2. So this is horizontal stretch. And then horizontal compression is what? Multiply x by the reciprocal of 1/2, which is 2, right? So that is horizontal compression. So this is the rule. So use the rule so that we can graph it, and then also we can find the equation of g of x. Okay, let's try. Let's do an example. Some examples. So let's say f of x. Okay, f of x equals square root of x. All right. Then when we shift 2 units up, then the g of x is equal to what? F of x plus 2, right? F of x plus 2. So what we're going to do is add the whole y value, whole expression of f of x by 2. That's it. So this indicates the graph is what? Shifted 2 units up. How about shift 2 units down? That means just subtract 2 from the original function f of x. So the graph of g of x is what? Shift the graph of f of x 2 unit down. All right, and then how about the horizontal shift? Okay, the horizontal shift is we change x, change the variable x. So that is x what? X minus 2. So x will be replaced by x minus 2. Then the graph will be translated, shifted 2 units to where? To the right. So minus means to the right. How about this one? The graph, so we will use x plus 2. Replace x with x plus 2. That means the graph will be shifted 2 units to the left. Okay, makes sense? All right. And then vertical stretch by a factor of 2. So vertical stretch is what? Multiply f of x by 2. So f of x is square root of x. So multiply this by 2. So the graph will be stretch it, vertically stretched by a factor of 2. So all the y value is multiplied by 2, right? How about the compression? Vertical compression is multiply y value by the number that is less than 1. So this is the graph will be compressed by a factor of 2. So all the y value will be reduced and will be multiplied by 2. Okay, how about the horizontal stretch? Okay, for the horizontal stretch, horizontal, when you use a horizontal, then always change the variable x. So in this case, we're going to multiply x. Multiply x by the reciprocal of 2. So that will be 1 over 2. All right, so the graph of g of x will be what? This is the horizontal stretch of f of x by a factor of 2. Okay, and g of x. Now, if x is multiplied by 2, then the reciprocal is what? 1 over 2, right? 1 over 2. So this is horizontal compression by a factor of 1 over 2. Can you see it? Okay, how about this one? How about graph? Should I graph it? All right, if we graph this one, Actually, not need to. We don't need to graph it. Okay, let's try another one. F of x equals now. Let's use 1 over x, something like this, 1 over x. Then shift the graph 2 unit to the right. Then what is it? F of x, write down the expression for the f of x, and then plus 2. That is shift 2 units, shift 2 units up, right? Shift 2 units up. How about 2 units down? Shift 2 units down, then write the function f of x, and then minus 2. So the graph will be 2 units down. The graph of f of x will be shifted 2 units down. How about horizontal shift? 2 units to the right. 2 units to the right, then what do we do? Replace x with what? X minus 2, right? X minus 2. So x is replaced by x minus 2. So the graph of this will be the graph of f of x 2 units to the right. How about if you shift to the left 2 units to the left, then replace x with what? X plus 2. So 1 over x. So this x will be replaced by x plus 2. Okay, how about vertical stretch by a factor of 2? Vertical stretch means multiply 1 over 2, the f of x by what? 2. That's it. So if you rewrite it, then 2 over x. Okay, and then if you multiply the original function by 1 over 2, then this is vertical compression by a factor of 2. So if we rewrite it, then it will be 1 over 2x. Okay, and then if we want to translate horizontal stretch by a factor of 2. Horizontal stretch, that means you got to multiply x by what? X by horizontal stretch by a factor of 2. Factor of 2, so reciprocal of 2 is 1 over 2, like this. Then if we rewrite it, then it's going to be 2 over x, right? Okay, and then finally, when you do a horizontal compression by a factor of 2, horizontal compression, that means what? Multiply x by what? The reciprocal of 1 over 2, which is 2. That's it, right? Can you see it? All right. So I hope you understand this one. So this column is related to this function, and the last column is related to this function. So each function is changed based on the type of the transformation. Okay, transformation indicates translation, shift. This means shift, translation, right? Translation. And then stretch or compression. Okay, stretch or compression. So vertical stretch, vertical compression, horizontal stretch, horizontal compression, shift up, down, or shift right or left. Okay, that is called transformation. So when we apply this type of transformation, the function is changed based on the rule. So make sure to understand this rule. Then once you understand this and can apply it, then it will be much easier, when you do the next, all the way to the other chapters, then it will be much easier. So please make sure to get these transformation rules. All right, that's it for this section.